Okay, question 1 from tutorial 6. Air substance enter in axial compressor as shown in figure at a 101 kilopascal absolute pressure and 27 degrees centigrade with a average axial velocity component of 1.5 meter per second. So at the inlet, your pressure, so if you consider inlet position is a 1, so at position 1, pressure given 101 kilopascal, temperature given 27 degrees centigrade, velocity given 1.5 meter per second, and substance is here. Now find the mass flow rate through the compressor. So we need to find out the mass flow rate through the compressor for part A. Now for part B, we have one more section. So write down here, so we need to find out mass flow rate. So mass flow rate. Okay, and part B is absolute pressure and temperature at point 2. So at point 2, say here, say point 2. At point 2, pressure given 202 kilopascal and temperature at point 2 given 87 degrees centigrade. And air mass flow rate, say mass flow rate at 2 is given 5.53 kg per second. Now we need to find out for part 2 is your average axial velocity at point 2. So we need to find out velocity at point 2. So two cases. Now for the first case, say mass flow rate. Say mass flow rate at point 1 is basically equal to formula is your density of air at location 1 and your volume flow rate at location 1. Now for density, we need to find out density at point 1 location and volume flow rate at point 1. Then we can find out the mass flow rate. Now our air is substance. So air is ideal gas. So we can use the ideal gas formula to find out the density. It will be equal to pressure divided by RT. Now we will find out for location 1. Say for location 1 density, it will be equal to location 1 pressure, location 1 temperature. And R is the gas constant. So this one independent from your surrounding temperature, surrounding pressure is always constant for air. Now we'll find out here R from property table. A1 for air R equal to 0.287 kilojoule per kg Kelvin. We this one find out so many times. So let's show you the property tables. So here the property tables, the A1 substance is air. We are looking for gas constant R and below is 0.287. Unit is kilojoule. You can see here unit given. So kilojoule per kg Kelvin. So let's back to the problems. So we got the R from table A1. Now rest of all are given. So pressure given 101 kilopascal and temperature one given 27 degrees centigrade, and you can see your R unit is in in Kelvin. So and currently your T1 in centigrade. So we need to convert centigrade to the Kelvin, otherwise it will be the problem with the unit. So now put the all values. So P is given 101 kilopascal, so 10 to the power 3. R is 0.287 kilojoules, so 10 to the power 3. And T is 27 plus 273. So we'll convert to the Kelvin. So from here, we'll get the density of air at location 1 is 1.17 meter cube, kg per meter cube. Now, still your volume flow rate is unknown. We need to find out volume flow rate. Then we can calculate the mass flow rate. Now let's find the volume flow rate. Now volume flow rate is formula is, if you know the velocity, we can use the velocity times your area where air will flow through this area. Now velocity is given as 1.5 meter per second, and area, so here, so location 1 area will be this one. So they give us the 2 meter diameter, so we can find out how much area will be at here. So air will flow through this area. So both of them is given, so let's use them. So 1.5 meter per second velocity, and area is pi over 4 diameter square. So diameter is given 2 meters, so 2 meters square. So we'll get the volume flow rate equal to, so we use the location 1 value, so it will be volume flow rate for location 1, velocity also at location 1, area also at location 1. So it will be 4.71 meter cube per second. Say volume flow rate at 1. Okay, now we got the required parameter for mass flow rate at 1. We have the volume flow rate, we have the density, we can find out the mass flow rate. So let's find it. So mass flow rate at 1, it will be density at 1 times volume flow rate 1. So equal to 1.17 times 4.71. So equal to 5.51 kilojoule per second. So this one answer for part A. Okay, so first we write down the given parameters, then we write down the what we need to find out, say mass flow rate. Then we write down the formula. From formula we identify this, we need to find out first these two, then we can find out the mass flow rate. So we use the ideal gas equation because air is ideal gas. We calculate the density, then velocity was known, area was known, so we use the velocity and area, we get the volume flow rate. Then we multiple with the density, we get the mass flow rate for location 1. Now part B for this same question. Now your pressure for location 2 given, temperature given, but mass flow rate also given, but volume flow rate, we need to find out the velocity. Now we know the formula for volume flow rate is related to velocity and area. So now we are looking for point 2, say point 2, point 2, point 2. So we will find out the velocity for point 2. It will be the volume flow rate for point 2 divided by area. Now point 1 area is point 2 area is fine, we can find out, but volume flow rate is unknown. So let's find out the area first. Now you can see the location 2 is here, and This on the air compressor axial cross section view. So here is say your compressor wall solid part. This one is your compressor wall solid part. Now air will flow through in this direction, and it will exit from compressor in the from here this direction. But in between these two sections, inlet and outlet, you can see there's a one solid part. This on the solid part, and this solid part diameter given 1 meter. So air will follow. If you draw the air stream, it will flow like this direction. So it will follow in this direction, and it can't follow in here because this one is the solid part. Now in formula, required area is the where air will pass through the compressor. Now if I draw the say cross section view, so if you look from this side in this angle, then if you draw the cross section view, your cross section view will be look like this. So outer diameter of your compressor is a 2 meter, and inside there is a solid part, diameter is 1 meter. Now at location at point 2, your cross section view will be this. So air will pass through in this free space. Now so area 2, it will be the, if you consider the whole thing as a first as a hollow, so pi over 2, sorry, pi over 4, then your diameter square for whole section, the whole big one, then minus the solid part because air will not pass through the here, so pi over 4, so your small one diameter is square. Okay, so area, or we can write down say pi over 4, 2 square minus 1 square. So area is done. Now we need to find out the volume flow rate. Let's volume flow rate from the first part, if you remember. So mass flow rate is equal to was density and your volume flow rate. Now we'll find out for location 2, say location 2, location 2, location 2. Now your volume flow rate, it will be equal to mass flow rate for location 2, density for location 2. Now mass flow rate for location 2 is given 5.53, but density is unknown. So we need to find out the density for location 2, then we can use this value so we can get the volume flow rate. Now density at 2, we can find out from pressure is known at 2, air gas constant R is known from the property tables, and temperature at 2 also known. So we can find out from here. Let's find out density first. Density, this one given 202, 10 to the power 3, R given 0.287, 10 to the power 3, then T2 is 87 centigrade, so we'll convert to the Kelvin. So finally density for location 2, it will be 1.96 kg per meter cube. Now if you use this density, so we'll get the volume flow rate. So mass flow rate is given 5.53 and density at 2 is 1.96. So your volume flow rate will be 2.83 meter cube per second. Now we have the area here, we have volume flow rate here. If you use this value, so finally your velocity at 2, it will be 2.83, then divided by pi over 4, 2 square minus 1 square, and it will be 1.20 meter per second. So your velocity at location 2 will be 1.2 meter per second. That's it.